உங்ககிட்ட நான் கற்றுக்கிட்டு ரமேஷ் எங்ககிட்ட ஷேர் பண்ணுறீங்க நீங்கள் ஷேர் பண்ண சொல்லுங்க.
சுரேஷ் ஒரே சைடு ஒரே நேரத்தில் 3 சைடு பாய்க்கிறாரு செய்கிறாரு.
நான் 3 வருஷத்தில் இருப்பேன் ஆள் 3 இடத்துல
ஃபோன் கால் மேனேஜ் பண்ணு. அந்த லைட் எடுத்துருங்க. இந்த லைட்லாம் அப்படியே இருக்கல. ஒரு லட்சம் நல்லா இருக்கும். ஏகணும் கூட தான் அடிக்க போய் பார்த்துருக்கேன்.
எப்படி அடிக்கிறாங்க
ஃபேன் கூட.
ஸோ இதான் RMU. இந்த போர்ஷன் வந்து தெரியாது இருந்துச்சு. We didn't know this portion. We were talking about only one RMU.
Yeah.
When we went there, they have 2 RMU in clinic, which we didn't know.
But in the drawing shows one only.
Yeah, it's drawing. That's why a bit of a thing we were not uncertain. So this one, TNB operate. This is compact substation. Until here, this compact substation. The TNB comes in here. This switch gear, this one is this dotted line is inside a vacuum enclosure. Filled with SF6. 1, 2 in, they call it 2 plus 1. 2 in, 1 out. So the day when we went, the TNB guy comes in, he off this. They off this one. This is the one that goes just beside that. They go back to here. One more RMU. Screen.
Yes, sir.
All right, thank you. Blackie.
So all the while we were talking only about this lah. This one we did not know it existed. This information I got, they said they have a transformer here. From it goes here. So I also cannot capture this. So on that particular day, TNB foreman came. Then there was a job card, work permit, everything prepared like what they prepared. They asked her to sign. And they went and switch off this and they grounded. Okay. Then we started working on this now. We started working on this. That means TNB incoming. And then they have one. This also, the RMU is mentioned like that, like 2 plus 1. 2 incoming, 1 outgoing. So this outgoing, this one spare, this outgoing through overhead. Go to also they have one RMU here. So this one 11 kV 415. This one is in this lab. So the problem is here. Problem was here. So this area, Also here is it's enclosed lah. So if you were to ask where is the protection relay and all that,
Sir, sorry sir. Shubha, relay?
where is the protection relay lah here? A4 relay, yeah? Normally circuit breaker VCB must have A4 relay, right? So where is the A4 relay? They have their A4 relay is built in. Inside itself is built in. Likewise, so another thing, they have two incomer here. They also call, it's a ring main, the in and the go out. And then finally all that loop back lah. That's another issue. So they have a built-in protection relay only for the outgoing. So inside this, I didn't see, don't know, but this one I saw. Outgoing, they have a protection relay here, but there is no external voltage given for the tripping coil. There is no external voltage. Like what we have 110, or if HT side DC 30 volt, have a battery station, right? Then it's none. So what actually is there is like this. So you have 3 bus bar HT. They have CT coil. One CT is common. Another one goes to shunt trip relay, and another CT straight goes here. The third CT goes here. Also shunt trip relay draw this way is equal conventional type . Two relays and these 3 wire joined together, and then they have one more is the this is ground. One more is they have this earth fault relay. Earth relay, and it goes to ground. And here they have the time lag fuse. This is the time lag fuse. Okay. This is the configuration. This is built in, it's already built in. We cannot, externally cannot tamper. It is inside the chamber, and this is a hermetic wire with SF6. So how does this trip work? Where does it obtain the supply? So the supply goes from induced by this CT. When there is inrush current, when current flow, this CT pickups go to this coil. It's totally different compared to our IDMP relay, where we give external supply and all that. So what happened? They have 3. This one overcurrent, this is fault. Let's say there they have this time lag fuse they have set to 7.5 amps. What is time lag fuse is? It delays for a while and then it will snap. If there is a current flowing through this and pick up by this CT, as long as it's below 7.5 amps, 7.5 below 7.5 amps pass through this, everything will be normal. Because it's like as though you take two bulbs, like if you take a put a battery and you short these two, what will happen? This bulb won't work, this bulb will work. The moment you take out this shorted, both bulbs will work. So similar theory, anything exceeding, that means during overload, this one will snap. We don't call it blow. Blow means it's for what? Cable, copper cable. This is a time like it's lead. Slowly it melt and give way. When it give way, the voltage will try to pass into this actuator coil. So it magnetizes. You have a plunger, and the plunger trips the mechanism of that breaker. This breaker is outgoing. Here there is a breaker. There is a disconnect switch, it trips. That is how it works. Then if there is an earth fault, this fellow will capture immediately. All the current goes this way and then, because this bi-directional earth fault. If as long as zero, all zero, it will remain. But this one, it will try to capture if more than 7.5 amps in the CT, it snaps straight. But this one, it always measures zero. So that's why it's bi-directional. It will capture and it will read. The plunger, the spool, the plunger, this plunger will be sitting on common flat. It will be sitting one here. So any one of the pushes flat, it trigger, it go in try to the mechanism. They drop into the mechanism and trip. So this is original, and we had this circuit, only this we had. What has happened? They have introduced external protection relay. So the external protection relay, the extension protection is macro 2200 something like. They are using this. This is combination of overcurrent and earth fault, which is already built in there. And this one we cannot tamper because this portion is already inside this hermetic seal. Inside there. So this relay 37, 38 terminal, it's a normally open contact, and here they have this 30 volt DC plus minus. What they have done, they have looked to these external people have done, and the CT coil, they use this CT. This terminal come to a junction box. So don't know how they have tapped and give it to the CT slab. So we don't know how, because we didn't have the drawing, which is the modification drawing. And there are some clause, if you want to put an external protection relay, you need some approval drawing.
This additional thing done by some other people.
Some other, we don't know.
It is still there, huh?
Yeah.
See the door.
Maybe the
Okay. We didn't know.
Mr.
So we were called.
Give us 15 minutes. Alright.
So we were called to rectify what went wrong. One of the
Sorry,
city,
short one.
one of the cities,
Okay,
sorry, one of the tripping coil is burned. The shunt trip is burned. It was this one was happening about 10 months. I think another people went in, so I haven't solved. But at the end, we were called. So we went and found one shunt trip is burned, and we wouldn't know whether it's a earthward shunt. Overcurrent is a red phase and the blue phase. So yellow goes direct. So we didn't know. Finally we got the spare part. We went there and replaced. This one all can be seen. This is exposed. Only the isolator is enclosed because 11 kV switching and all that, you cannot expose. As if which relay, we change one relay. We come back to the junction box, we do the connection and everything. Then we put back the wiring as what it was earlier. So when the calibration people inject current, it didn't trip. None of these three shunt trip didn't even check. Didn't work at all. Is C0, also C0, and this is C10, C30, C30 and C70. This number can be seen now. So what I did, I took out all this number and tried, because this didn't work, so I was working one side and they were trying to trace on one side. Then I saw this wire, since there is a 30 volt I have already given to terminal 37, and they simulate this so that this contact will close. It comes to 38. So 38 here they written is trip 1. They name that cable as a trip 1. And this one they put a connector, come out. They went and connected to this. Connected to C0, but don't know which C0 because we cannot trace the wire. So it's connected to one of the C0. Assume it's here. Assume here. It was connected. And then this one supposed to go to a relay. Which relay? So this is supposed to go to a relay. So this went to C30. So it went to this terminal. This terminal. So that means a power, external power has went into this CT. It went into this CT coil, come back here, and then went to this solenoid, this shunt trip, and back to this way. That means there was a complete circuit. So when they were tracing, they said, why I can get here 30 volt, and here when they measure it was only 16 volt. There was one time I have experienced this. If you have that, you straight away must go to the battery bank, battery charger, and the battery charger, the DC battery charger, they have few lights, see what any blinking. So I went, so there is a DC fault. So when there is a DC fault, we know that the DC somewhere is shorted. So while I was doing that, the calibration people felt there is no neutral for this relay to trip. That's why it's not tripping. So what they did, assume this is the coil. So they open this coil, they open the wire, and they join one wire, and then they connect to this negative. Connect to this negative. They cut this. When they do that, I said cannot lah. You cannot do that. Yeah, it trip. After that it trip because you have a positive here, it straight goes to here, this end. They cut here and this coil, they put the negative here. So when these calls, they simulate this relay, the positive goes here, go and open this, call this relay. But at that time, that's why we don't know, it cannot be like this because this fuse will blow off. So very possible it's not this relay lah. They would have called this and it tripped. That's why I told you we don't even know which relay, the three relay we couldn't trace. They didn't trace actually. They were doing it. This is what happened lah. For now it tripped, but they have took out this wire.
It's not right as well.
It's not right.
Yeah.
It's not right. So this is the whole scenario has happened now. Now we don't know how to trace who instructed. I did some study. They said this one cannot be tempered at all. If you want to put this one, Tenko must give a drawing. And before that they say you don't need an external tripping relay. You don't need because it's already there. It's already there. If they want to change the setting, they only set this time-like fuse to higher little bit, maybe 8, 9, 10, depend.
This external one, now who actually installed the external tubing circuit?
Who installed?
I don't know. There must be a reason for that to do that. Maybe before this is not working.
Nobody have any document. They already asked. They already asked the areas. Nobody asked. So now what we can do, we have replaced. Then the final one, when we simulate, when we did the simulation, assume this is the relay, assume this is the relay that burned. So we went and replaced this new relay. But when we simulate, this relay didn't trip. It went and tripped this relay.
So that means if there was a fault, that relay should have tripped, right?
Yes, the question then, if there is a fault, this relay should have tripped.
Nothing to do with the burnt relay, right?
Nothing to do with the burn relay.
Oh, that's why I suspect this Tenko inside internal thing is not working before something happened. That's why they come out with the external.
Yeah, could be one of the reasons.
So I think the best way to solve this thing, we go back to Tenko.
Tenko, they said no, we only sell our product. Thereafter, what happened? Unless, because now it's already tempered, and warranty period finished already.
No, actually, at least we can get their.
Already read to, he already wrote to them.
Because
They give any.
They give the drawing just today morning, but that additional don't have the drawing.
No,
Only that.
not tripping. Found out there is no neutral. It's going in series to another coil coming out. So what he did, he cut here, take one negative, and join to this relay. That means this one particular relay will be tripping. So there is some case study has to be done. Which relay was there?
You are saying that that particular relay should trip when they do the stimulation, but it is trip on top, right?
This is the burn relay.
No, the center one.
Center one. Is that? That's why I don't know where have we connected. I asked him, have you traced these two? Which one? This wire belong to Number one, we consider 1, 2, 3 lah. Is it these two wire first relay, these two wire second relay? He said he didn't test.
So maybe they have put wired the wrong one.
So first thing we need to know that wire in the junction box, the 6 wire belong to which relay we identify. But we know which is like a C10, C30, C70. We know which is the overcurrent relay. 2 overcurrent relay, 1 is the earthward relay. That's why I asked Prashant to help me on this. Look for some who have experience to discuss with them. And Jaipal, meanwhile, he brought to TENCO to get some information. With that, we will go in. We will make it right. We make the wrong, we make it right, so that we can bill to them, and then we will be happy that they have done the job correctly.